In this video, I'm going to show you how you can use QuPath to identify the cells that are associated with markers with an object classifier. So previously, we segmented the nuclei. If I zoom in, I can see them. So now the idea is to identify each marker. So if I go back, so I have DAPI. So DAPI, I used it to segment nuclei, and now I want to identify all the cells associated with Tibet, CD8, Aurora gamma T, CD4, FOXP3, and cytokeratin. And so we could use the special DIN tool that we used for the DAB to identify DAB positive cells. But we can also do an object classification, in which case we take into account the intensity, so we can take into account the average intensity for a nuclear marker in the nucleus, for example, but also the minimum and maximum intensity. We can also take into account standard deviation, everything that's happening in the nucleus. And that should help, especially as fluorescence is not the same across the image, and here clearly it's not the same across the image. So if you just do a threshold, if you have one region that is brighter than another, you might get positive cells in the brighter region that shouldn't be positive if you want to have positive cells in the not so bright region, or the other way around, just positive cells in the bright region, and the other regions you can't get anything. With an object classification, by taking into account the, for example, standard deviation inside the cell, all the minimum and maximum, you have all the features that you can use. So even if the intensity is different, the variations inside your nucleus are other features that can be used to identify your positive cells. So to do this in QuPath, you have a nice feature which is duplication of all your channels. So you duplicate your image for all your channels. So when you do that, just make sure that you actually save your image, so that, for example, if you did the nuclei segmentation, you have your nuclei, but if you don't save the image when you duplicate it, you won't have the nuclei. You need to save it. I just did it with Ctrl S, or you do File Save. And now I can duplicate. So if I do Ctrl L and I look for Create Duplicate Channel Training Images, so then this window pops up asking for which markers we want to do it. And basically we want to do it for all of them except DAPI, because we don't have any. So DAPI was, again, just used to segment the nuclei. I can OK. Now if I go to the project, I have my image and I have a duplication for each of the markers. So I'm going to start with Tibet. And so then it makes sense to only look at the marker associated with Tibet. So I'm going to go there and look in grayscale, because the human eye is better with contrast in black and white. And I'm going to light on Tibet. So here, when you don't have anything, sometimes it's a bit hard. So here we see it. All right. I can put back the segmentation, and now I can actually label positive and negative cells. And so to do that, there's this annotation tool that's pretty nice, where you can add. So here I can add two groups, one for negative cells and one for Tibet positive cells. So I need to create a new class, which is going to be Tibet positive. All right, and I can set this class, this group of points, as Tibet positive. This one I'm going to assign it to ignore. You could you could define it as a new class, Tibet negative, but you would have two classes for each marker. So you would have many classes, and it's just, you know, it's the same information. Tibet positive and Tibet negative actually is the same. It's either positive or negative, so you can have only one mark. And so I'm gonna define a few positive cells. So when you do that, you can just select a nucleus that is positive, and then you have, so this tool, which is actually doesn't matter. This is just to show you where it is. So in our case, it makes sense to have something that is about the size of a cell, but that doesn't matter. What is taken into account by the classifier is where you click. At that point, it knows that it's inside this cell, so that's for this cell. So you can define a few examples. What is important is to have something representative. So this one is fainter, but I think it's true. Then you have to wonder, is it a positive cell? I don't think so, because it's a bit, so either it's an under segmentation, I should have several of them, like 2, or it's just non-specific, so I'm not going to use this. This one I think is true, this one too. So I have bright ones, I have less bright ones. Let's take this one. So I can start with that. I have 5 cells for Tibet positive. Now I'm going to define 5 for negative. So this is pure negative. And it's important to have also cells where you think that you have non-specific fluorescence, so then it's going to be able to identify them. So this, I think, is not positive. It's not. You can navigate and go a little bit further away, and let's define, I don't know, this one, for example. So now I have 5 points for each of them. I can start to train an object classifier. So if I do Control L, I can look for train object classifier here. So it looks like the pixel classifier, except now instead of pixel, it's objects. So by default, it's random trees. Could use also the artificial neural network. I'm going to keep the random trees. For the features, either use all the measurements, or you can filter them by output classes. And here, my output class, as I defined images, is Tibet. So if I do that, it's going to use all the features where Tibet appears, or you can define them. So for example, it makes some sense. Here, we're not going to use any morphological features, but you could if you knew that you're looking for cells that you know are smaller. For example, you could use the area. But here we know that, so we're looking for cells that are Tibet positive and Tibet in the nucleus. So I'm actually going to check everything where I see Tibet and nucleus. So I'm going to have several features. I'm going to use the average, the median, the min max instead of the standard deviation. I can apply it, and now I can do live update. And so it's going to try to identify Tibet. So here nothing is positive, and it's because I didn't define enough examples. And not only, you know, it doesn't mean that it's not enough positive examples, could be also negative. If I add, for example, these are the negative cells. If I had one like this one, I need to go back here, sorry. I might see a few things. No, so I'm going to add another one. And I'm going to add positive ones. Like in here, and this one. And I still don't see anything. So let me just, oh, I forgot the live update, so that's not going to work. Sorry. So when you do the live update, now you can see that, so the positive ones are shown. So let's go to a different region. So you see the positive ones are in, are outlined in yellow, the color of my class. And so here I can update it, like if I think, sometimes it's nice to go back, so that might be real actually. So if I think that some of these are not positive cells, I could change, so add them to negative. That looks okay. But so for example, this, if I think it's positive, which I think it is, I can actually add one as to the positive. It might add other ones. No, it didn't change. So it's oh, live update. I put it off and switch it off again. I don't know what I did. Let's see if I add this one, for example, does that change? Yes, so it adds the other ones. So then I need to see if this is real. It probably is. Yeah, it probably is. And so then maybe this is as well. And so you can navigate like this and see there are some that you don't agree with, that you think they are not specific. Like, you know, this one doesn't look like a structure, but I think should be on. So I'm going to remove it. Doesn't change the other one. The other ones are strong enough to keep being selected as positive. So then, you know, here it's pretty hard. I guess this one might be positive. But what is important then is to make sure that you know your markers. And here it's a difficult exercise. Here it's a correct one, but it's just a segmentation that wasn't correct. Maybe we can just say that this should be ignored, and all this shouldn't be ignored. And I guess I remove the live update, and now, you know, it removed everything. But maybe it's a better decision. It's also up to you, because now I put it back, and I think it's fine. You really need to know your markers to know what is real or not. And this is not my study. I work with people in this study, but this is not my study, so I'm not sure about. So here clearly, at least this one is not. Oops. So I'm gonna ignore this one, and now it ignored the other one. But here it's more a problem of segmentation, and that's something you're gonna come across as well. So you can just navigate like this. And so again, it's not my study, so I haven't worked on this specific marker, and I'm not sure what should be positive or not. For example, this, I don't know. Probably it is positive. I'm gonna add it. And so on. And so let's say you're happy with it, then you need to save your classifier. So I'm going to save it as tbet positive. All right. And then you can switch to the next image, so which is going to be CD8. I'm going to save it so the annotation are still there. So if I want to go back and adjust my classifier, I can do it. So here I want to look at CD8. So I'm going to look at CD8 here, and so then same thing, you know. So you add a new class, add class CD8. I'm gonna add two groups, one for CD8. Oh yeah, let's do something that is more consistent across. So CD8 plus would be better. Can I change the name? I don't think so. So it's fine. I'm just gonna remove it and add it again. So I have something consistent plus. All right. And I'm gonna set class to CD8, the other one to ignore. All right, I'm going to define a few examples. CD8 is cytoplasmic, it might be a good idea sometimes to switch on. You see that that segmentation was pretty good, I would say. So it's definitely positive. Some fainter like this one or this one. Let's define a few negative. This is highlights in between. This one or this one, or I guess this one is negative as well. This one, and then I can start an object classifier. So I just wanted to show this one because here what's going to change is the features. Now we want to use everything that is associated to CD8, but not really the nucleus, but the membrane, because it's a membrane marker. So I'm going to check everything that is membrane and CD8. All right. So you can look at the cytoplasm or at the whole cell, depending on your marker. Sometimes it might be better. Apply it, and then you can do a live update. And everything is positive here, for example. So I can add one, and you see now it's getting better. So these are positive as well. So I'm gonna do it for all the marker, for each marker. Save a classifier for each marker, and then I'll be back to show you how you can then apply your classifiers to all your cells. All right, so I'm done with my object classifiers. So I train an object classifier for each marker, and so now I can apply each of this object classifier to my original image. So if I do Control L, click inside, Control L, and then load object classifier. Now all the classifiers I saved in the project are there. So I have cytokeratin, Tibet, or gamma T, CD4, CD8, FOXP3. So for each marker, I don't have DAB because I thresholded the DAB in the HDAB image, but I didn't save the thresholder, so it's not there. But if I had saved, it would be here. Anyway, these are all the classifiers I want to use, so I'm going to select them all and apply classifiers sequentially. And so, I guess it's down. So if we zoom in, so now if I double click on one cell, if I go in the annotation tab, I have a class. So this one is cytokeratin positive. This one, for example, is CD4 positive. This one is CD8 positive. Let's try to find one which is double positive, Tibet and CD8 positive, and so on. So I have all this information. Something I can also do is to load my pixel classifier to get the epithelium and stroma. So if I do Control L, if I look for load pixel classifier, so I have the two I had trained, the one for the H&E, the one for fluorescence. I'm going to use this one, and then I want to define it everywhere, and I can create objects for the full image. So you can try to improve by filtering out the small objects and filling holes. I'm not going to do it, but I think it could help here because I had some spurious regions sometimes. So yeah, here I'm filling the annotations, it's down. And if I look at here, I have my three classes, epithelium, stroma, and background. So I'm going to remove the background because actually I don't really need it. I'm going to delete it. But now I have the two other compartments. So again, it's not perfect, but it's kind of okay. If I now it might be interesting to look at the measurements. So if I look at the measurements associated with the annotation, so I only have two annotations here, epithelium and stroma. The nice thing is that I can have, so if I go at the end, I have the area for both of them, which might be interesting. And then for each class and combination of classes, I have a number of objects. So for example, I have 25 CD4 positive cells in the epithelium and 1,052 CD4 positive cells in the stroma. Across 62,550 total cells in the epithelium, 25,986 total cells in the stroma. And so you can look at your different combinations. So here, as we identify each marker independently, it's very much possible that we end up with combination that we are not expecting. And so maybe we can do some post-processing if we assume that some combinations are not possible and that, for example, we have a cytoplasmic marker that is more likely to spread out and maybe consider a cell positive for this cytoplasmic marker where it's not. That's a possibility. And it really depends on your study. You have to be careful. But anyways, for example, we have 48,000 cytokeratin positives in the epithelium, which makes some sense, and so on. So for example, cytokeratin and CD4 positive is not possible. Here, one possibility would be to say that cytokeratin is cytoplasmic. So maybe I have cells that are considered cytokeratin positive, but actually are not, just because there was some signal surrounding them and they were actually only CD4 positive. You have to be careful when you do these kind of things, and you definitely have to say, so for example, if you write a paper, you need to write in the methods that you did this thing. But if you explain why you do it, and if you give good explanation, then the reviewers can state if what you're doing is correct or not. And if we look at the the detection measurement, so here you're going to have a cell per line and then different classes. So obviously we have, so these guys are negative, they don't have any class, so they are negative for all marker. And I told you, so we can, if we zoom in, we can then do this. So that's a cell that is outside everything, so that makes sense, it's negative for everything, while these guys are cytokeratin positive, I guess. So if we go there, so this one is only cytokeratin. And so then you have all the measurements associated to your cells, including, membrane, cytoplasmic, cell, and nucleus measurement for each marker. And so then, out of it, you can do your analysis depending on if you're interested in different cell types and different cell compartments